One of the most celebrated finds in animal behavior has been the discovery of how the honeybee navigates. Bees must search far and wide for food. They gather nectar and pollen from wildflowers that may be as far as half a mile from the hive. They may be a different kind from time to time, and their yield may vary. There are specialized forager bees whose job is to find flowers and then tell the rest of the hive where they are. But random searching may take the forager far from the hive. The bee's problem is how to tell the others where it has been. The problem is compounded by the bee's vision. This blurred mosaic is roughly what the world looks like to a bee. Bee language is as complex as their social organization. This forager performs a repetitive dance which tells the others which direction to go in, how far to go, and what they will find when they get there. If the other bees want to know more, they make a special noise. These bees want to know what kind of nectar and pollen they should be looking for. The forager has brought some back, which they sample with their antennae. The dance is a diagram of the trip, telling the others what heading to take relative to the sun. Each time the bee runs up and to the left, it conveys the same information. To find flowers, steer about 15 degrees to the left of the sun. Direction alone is not enough. The workers have to know how far to go. Bees can count, so the forager tells distance by the number of times it wags its abdomen. In this case, 1, 2, 3, 4, 5, 6. Experiments have shown that this translates to 300 meters. With a heading and a distance, the bees now have the right directions. They're looking for goldenrod pollen and nectar, 15 degrees left of the sun, 300 meters away. But they can't see very well, so what kind of navigational aids does the bee have that enable it to follow these directions so accurately? Since the sun moves an average of 1 degree every 4 minutes, 15 degrees left of the sun isn't accurate for very long. So the bee must compensate for the sun's movement over time. The bee does this with a clock, accurate to within a few minutes over many hours. But no one has any idea just how this internal clock works. More is known about the solar compass in the eye of the bee that keeps it on course. A bee's compound eye is made of hundreds of tiny hexagonal lenses. Like a telescope, each lens sees a very narrow field of view. By sighting the sun through the correct lens for a particular time of day, the bee can hold a constant heading as it flies. And as the sun moves, the bee's internal clock tells it to sight through a series of adjacent lenses. Once it has a heading, the bee must measure the distance it was told to fly. For this, it has an odometer, which works by monitoring fuel consumption. The bee tells how far it has flown by measuring how much energy, in the form of honey, it's used up. A good thing, because it leaves the hive with only enough honey for the trip. Because of how a bee sees the world, vision alone is not enough to guide it on its way. Instead, it has an array of senses that act like sophisticated instruments. The bee learns the way from its mates and also from experience, and it travels many times a day.